Hello everyone, and welcome to part 4 of the OAuth and OpenID Connect Getting Started screencast series. My name is Travis Spencer, and in this episode I'm going to talk to you about how you can protect server-to-server communication with OAuth. In particular, I'm going to talk about a new flow in this presentation called the client credential flow. To help understand this better, I'll also give you a demonstration of that flow using OAuth tools. Then we'll look at different client authentication methods, including mutual TLS, which we'll dive into, and conclude with a demo. As we begin discussing the use of OAuth to protect server-to-server communication, it's important to remember the different actors that are involved in OAuth. As you recall from the second in the series, we discussed the actors being the resource owner, the authorization server, the client, and the resource server. When making server-to-server communication, these entities still exist, but not in the same way as with the code flow and some other flows defined in OAuth and OpenID Connect. In this case, the resource owner will be an organization or a company that is owning the resource that is exposed by the resource server. The client will need to obtain an access token, and that token will represent the rights to consume that API on behalf of the organization, the resource owner. But this sort of delegation will be implicitly defined by the server being set up and installed. But in any event, the client will still have to obtain a token from the OAuth server, and it will do this using a new flow that we'll talk about in a second. But once it obtains this token, it makes a call to the resource server in the same way as we discussed in the last presentation. So what you might ask yourself, though, is why bother then? If the client is going to have to make a call with the API, to the API itself, why not just have a different credential that represents the client and to validate that when the API is called? Why go through the trouble of calling the token service to get this token when the resource owner isn't interactively involved? Are we making too much work for ourselves, and should we just skip it and not bother? The reasons that we don't want to do that is because the API now has a single security model. It only validates tokens, whether it's being consumed by a service or a client like a mobile application or a web front end. It has one security model, which is it accepts tokens. And what's more is it accepts tokens only from one entity, its trusted OAuth authorization server. So as a result, we have a less trust in the deployment. We have a single point of trust where all of those APIs will accept tokens solely from that entity rather than trusting every client and every credential. As I just mentioned, this server-to-server communication is done with a token that is obtained by the client using a new flow called the client credential flow. This flow begins like many others, where the client will make an HTTP post request to the OAuth authorization server's token endpoint. The contents of the body will be form URL encoded. The contents of this message will include a grant type with a parameter value of client credentials, signaling to the authorization server that the client is requesting to do the client credential flow. It may also include some scopes, and it will authenticate itself, perhaps using a client ID and a secret. The response will include an access token. It will include some scopes. These may differ from the ones that the client application requested depending on the authorization server's policy, and it will tell the client how long the access token is valid for by including the expires in value. Once the client has the access token, it can call the API like we discussed in the last session, and there the API will be able to figure out who the client is and whether or not it should return that resource or provide that capability to it. To see better how this works, let's demonstrate it using OAuth tools. You probably saw this in previous episodes of the series, but in case you didn't, this tool can be accessed by going to oauth.tools in a web browser. There you'll find this web application that works similarly to Postman, but just for OAuth. I've configured an environment here where I pointed to my OAuth server and created a client that can do the code flow that we've just been talking about. So from the Flows menu, I click that and I select the client credential flow. I pick the client that is configured with this capability. In this case, I won't ask for any scopes, but here at the bottom, it shows me that in order to do the client credential flow, a post request is going to be made to the token endpoint of my authorization server. Authentication will be performed in this case using basic authentication. The message will be form URL encoded, and that will include a grant type of client credentials. If I want to, I can change the authentication method here to use secret post, and then the client ID and secret will be included in the body of the HTTP request. Now I can run this. When I do that, I'll get an access token. In my case, it's a GUID access token, but it doesn't much matter. It's opaque to the client. Now what I can do is I can make another flow and call an API. Here I can paste in some sort of API that I'm going to call and select the HTTP method and the token that was retrieved in the previous flow. Here it's showing me the kind of request that's going to be made using that authorization bearer and then the GUID access token. If I send this request now to the API, it shows me that it sent the authorization header, and that completes the demonstration of the flow that we just talked about. So far in this series, we haven't talked much about client authentication, so we should probably unpack that a little bit. In all the demonstrations so far, we've been talking about authentication using a client ID and a secret. As we just saw, this can be communicated to the authorization server in different ways. Using basic authentication is mandatory to implement according to the specification, so you can always assume that the authorization server can understand that authentication method. But you can also form URL encoded in the message body, or even use digest authentication or something else. So there are lots of different ways of authenticating the client using a shared secret. Another example is to symmetrically sign a JSON Web Token. So if the authorization server and the client both have a copy of that shared secret, it's possible for the client to digitally sign a JSON Web Token and send it to the authorization server to prove that it is the client that the authorization server thinks it is. To also have non-repudiation, what we could do is we could use asymmetrically signed shots instead. In this case, the OAuth client would use the private key, and it would sign a JSON Web Token and send that to the authorization server, who would verify it with a public key. If the digital signature validated the contents, then the authorization server would know that the client that is communicating with it really is the one that it thinks it is. So if the client wants to roll its key and use asymmetrically signed shots like we just described, it wouldn't want to have to update the public key at the authorization server every time it did that. So what it might want to do is to have the JSON Web Key Set URI configured at the authorization server. So when it sends a JSON Web Token to the authorization server, if the token can be validated, the authorization server could fetch the key from the JSON Web Key URI, find the new public key that the client has started to use, validate that that incoming token, and see that the client really is who it's proposing to be. When it fetches that JSON Web Key URI, it will have HTTPS there and be able to validate that endpoint using a certificate authority that the authorization server trusts, and in that way know that the key that is being published from that URI is legitimate. There are also other ways, including mutual TLS. And I'm going to describe that to you in the next bit of the presentation. As we just talked about, it's also possible to authenticate a client using mutual TLS. To understand that better, and so that you can see me, I thought we'd use the whiteboard. So in this authentication method, as with all others, of course, we have a client. And we have the authorization server. The client wants to call an API, the resource server. In order to do that, it needs the token. To obtain that, it might use the client credential flow, like we've been talking about. So it will call the token endpoint of the authorization server, and in that include its client ID. But this time, the client will have a private key, and that private key will be trusted by the authorization server, either directly or indirectly through a certificate authority. So it will use that client key to establish a mutual TLS authenticated tunnel, and through that tunnel will flow a copy of the client's public key, the certificate. The authorization server, once it processes the HTTP message and finds out who the client is, will compare it with the policy of the authorization server to see that that key matches for that client. And if it does, it will issue an access token. And in that access token, it will include a hash of the private key that the client sent. And it will assign that to some sort of attribute that we'll call the confirmation method, or the CNF. And it will return that access token to the client. Now, the client will call the resource server, like usual, using the authorization header and signaling that it's a OAuth access token by including the bearer keyword and then the token itself. So what's different though is that here it will also do mutual TLS using the exact same key. So the resource server will trust that key either directly or indirectly through a certificate authority so that it will be able to establish this two-way authenticated channel. The access token will flow through that, as well as a copy of the client's public key and certificate. So now the client will be able to hash that public key and get that confirmation method, find inside of their access token the original confirmation method, and compare the two and see if they match. And if they do match, then the resource server knows that the client that presented that token is the same entity to whom it was issued. And if it was, then the token hasn't been lost or stolen. So this ends up being a proof of possession of this private key. So this works and is easy to do when the token is a structured token, when it's a by value token. But remember in the last session we talked about how sometimes tokens are reference tokens. So in this case the access token would be a GUID. And the only way for the API to know that the client is in possession of that secret key is for it to do an introspection. Like we talked about before, it needs to dereference that. So the introspection results will be JSON like we discussed in the last session, and the confirmation method here will include the hash that was originally computed of that private key, so the confirmation method, and then that will be returned to the resource server to be able to compare it with the confirmation method that it computed itself using a copy of the public key that was sent in this two-way authenticated channel. And if they match, then either using the by reference or the structured token, the API knows that the client is in possession of that secret key. So now let's drill into that and look at some examples to conclude this presentation. To understand better how mutual TLS authentication works together with the client credential flow, let's use curl. So in curl, we specify the key which corresponds to the circle key that we just drew on the whiteboard. That will authenticate the client to the server. In the HTTP request, we need to identify the client by including the client ID form parameter. And we need to signal to the authorization server that we want to do the client credential flow. So we include the grant type equals client credentials. And we send this to the OAuth server's token endpoint. And now we have an access token. And in this case, it's a by reference access token. So the client, it would dereference this like we just talked about. So here we'll use a different client that represents the API, and this one wouldn't do mutual TLS authentication necessarily. So in this case, I'll use basic authentication. And in the form, we would include the token that we just got, and we would send this to the OAuth server's introspection endpoint. And now we get back a bit of JSON that includes the confirmation method that we talked about before, and that's a JSON object that has the X5T pound S256, which stands for the SHA-256 thumbprint of the certificate that the client used when it established the mutual TLS connection to the token endpoint when receiving that token. So if we do the request again slightly and we just change the client ID to be a different one, we will actually get a JSON web token back. So now we've done the client credential flow again, but with a different client ID that gets a structured token. So now it can actually look at this without calling the um, introspection endpoint. So here, if I dereference that, I'll have the confirmation there as well with the X5T and the SHA-256 of that. And now the receiving client will be able to tell the confirmation method from the structured access token. We covered a lot of ground in this presentation. We started by reviewing the different actors that are involved in OAuth and seeing how that they differ when making server-to-server communication. We talked about how the resource owner is actually an organization or a company that is managing that resource and exposing it. We talked about the different reasons for actually involving OAuth in this kind of communication and how it simplifies the trust model and simplifies the security model of the API. We looked at how the client credential flow works. We ran through a demo in OAuth tools to reiterate that and help make it more practical. Then we talked about the different client authentication methods that are possible to use in OAuth and how they can be used with the client credential flow in particular. We drilled into mutual TLS by whiteboarding some stuff and then solidifying that also with a demo using curl. So if you're feeling overwhelmed at this point, you'll be happy to know that we've arrived at the halfway point for our learning course. So for the next presentation that will start next week, we're going to look at designing tokens for APIs and the different scopes and claims that you might want to include in those APIs. So get some rest, and we'll see you in the next session. And if you have any questions, don't hesitate to let us know. Thanks a lot, everyone, for attending. Bye now.